In the previous video, we defined an agent as a model plus the harness built around it. I'm Mehrdad, and today we're zooming into the operating structure at the center of that harness, the agentic loop. An agent is a loop, not a single model call. It takes one step, observes what happened, and uses that evidence to decide what should happen next. A single model call receives one prompt, returns one answer, and then stops with no chance to react. That works for rewriting a paragraph, but real tasks like debugging or investigating an incident unfold across several dependent steps. Each action reveals information that was unavailable at the start, and that evidence should change the next decision. The loop closes this gap by turning one-shot generation into a process that can learn within the run. One turn begins by gathering context, the goal, its constraints, and everything the system has learned during this run. Next, the agent acts by taking one concrete step, which is often a tool call against the environment. Then, the harness verifies the result, asking whether the step created progress or moved the run off track. If the task is not done, the new result becomes context for another turn, so the loop goes again with better information. If the goal verifies, the loop stops and returns the answer. Consider the visible task here. Fix a failing test. One prompt and one answer can only guess a patch from the supplied error and the model's prior knowledge. It cannot run the test, inspect the real outcome, or adapt when the proposed change fails. The loop reads the error, edits the code, runs the test, and brings the resulting evidence into the next turn. A failed attempt helps only when its result changes the next action. The power is not repetition. Every turn starts from new evidence. The model itself does not remember the previous turn, because each request begins with only the context supplied right now. Without the harness, separate calls have no shared goal, no retained observation, and no knowledge of what already failed. The stateful loop threads the goal and observations forward, turning isolated model calls into one connected run. That state still needs curation, because too little breaks continuity, while too much creates noise, latency, and cost. The intelligence is the model, but the continuity is the harness. React is an influential pattern that interleaves reasoning and acting instead of treating them as separate phases. Reasoning alone can produce a plausible chain that quietly drifts from reality because nothing checks it against the environment. Acting alone can fire tool calls without strategy, creating motion without a clear test of progress. React reasons about one step, acts, observes the result, and then reasons again using that new fact. Acting grounds the thinking, while thinking directs the acting. The same underlying loop appears in several common shapes, each adding a different control mechanism around the next step. A single agent uses the basic React loop: reason, act, observe, and repeat. A reflection loop adds a critic so an attempt is evaluated before the system tries again. Plan then act, maps the route first, executes it, and replans when reality invalidates an assumption. Multi-agent systems create nested loops, with an orchestrator loop wrapping the separate loops run by workers. These are the same loop, wrapped, repeated, or stacked. Verification does double duty. It checks the last step and decides whether the run is actually finished. A clean exit occurs when the goal verifies or when a guardrail triggers, such as a step limit, budget, or timeout. When verification is weak, the loop can retry the same dead end while producing valid-looking actions and no measurable progress. Nothing crashes, yet time, tokens, and tool costs continue to burn because the system cannot recognize that it is stuck. Stopping belongs in the harness design, not in the model's mood. The loop is the center of the harness because every other component either feeds it or bounds it. Context decides what enters each turn, tools define possible actions, and memory carries selected information across time. Verification checks results, while guardrails constrain which actions may continue and when the run must stop. Together, these components shape capability, latency, cost, and risk by changing what the loop can see, do, and repeat. Carry 3 ideas forward from this video. First, an agent handles multi-step work through a loop, so each turn can act on evidence from the previous one. Second, reasoning and action work together, while the stateful harness carries the continuity that the stateless model cannot retain. Third, verification and guardrails must define progress and stopping, or the loop can consume resources without moving closer to the goal. Once you understand the loop, the rest of the harness becomes easier to place around it. If this series helps you, subscribe to Multi-Agent Academy and connect with me on LinkedIn. Next is video 3 on the anatomy of a harness, the 8 components that feed or bound the loop. I'll see you there.